So thank you, Jeff. So our next speaker will be Dr. Vijay Shah of George Mason. It's funny because you were at Virginia Tech for a while before going to George Mason to become a assistant professor there. We didn't meet face to face until yesterday, even though we've been on this program for 2 years together. So it was very good to meet you. So you'll be talking about the overview of our project, OAIC, and I'll let you take it from there.
Thank you, Joe.
Professor Gedder, are we recording the session?
Yes.
It will be available for viewing later?
Yes, I apologize. I didn't start the recording until 10 minutes into Dr. Reed's presentation, but I'm just going to record the whole day. So
thank you. That was a Zoom question.
Okay. So thank you. Welcome, everyone. I see the entire room filled with bright faces here. So I'm really glad to see you all here. I hope you'll gain a lot more experience, hands-on experience with OAIC, and hopefully you will use that in your own research and experimentation. So let me give an overview before we go to the interesting part, which are the hands-on sessions. So OAIC stands for Open Artificial Intelligence Cellular, and as you can see, the idea is to have an open source platform that allows you to prototype and test the AI-driven RAN controllers, where RAN stands for radio access networks. So we completely focus on RAN, even though we understand that core and user devices are also key aspects of 5G network or a 6G network, right? So that's what we are going to focus today. Our team includes Dr. Mario Wick, Dr. Botang, Dr. Gedard, Dr. Tripathi, Dr. Jeffrey, and all our students. So welcome again, everyone. Okay, so this is the outline. A brief background. I would expect that you already know RAN and Open RAN enough, given that you are here. But still, just to make sure that we are on the same page, we are using the same jargons, I'll briefly go through it. And then we'll get into the OAIC platform, which is what the focus of today's talk is. OAIC platform has two key components. One is the controller, OAIC controllers, or Open AI-enabled cellular RAN controllers, OAICC, we like to call it. And then the RAN testing, which is day 2. So you will learn about testing tomorrow, not today. And then we will obviously give you a peek into what are the OAIC features that's already available and what would be made available in the next release, which should happen in less than a month or so in coming days. And then I'll give you the timeline and the roadmap for the future releases of OAIC, which includes both OAICC and OAICT. And then also how you guys can get involved if you're interested, and Q&A. Okay, so the background. So again, we are focused on RAN. So let's look at the cellular RAN. We already heard from Dr. Reed how 4G RAN look like and how 5G and 6G RAN is going to look like, right? So if you look at 4G RAN, it was monolithic, black box, and proprietary, right? So if you buy a particular hardware, then you have to purchase literally everything from the same vendor, right? With 5G, that's not the case anymore. We are disaggregating the RAN, right? We have control unit, distributed unit, and radio unit, right? It's very flexible and it's programmable, right? And that's where the role of Open RAN or the thing called RAN intelligent controller comes in, right? We have open cellular software, we have open servers which host all these different software, and that makes you run a 5G RAN or a 6G RAN immediately, right? So my prophecy is that from 6G to 7G, it will possibly just a software update. Okay, there won't be any more deployments of hardware unless you really have a big innovation in the radio or in the physical layer, right? Other than that, I see that it's mostly going to be software update like we have with Facebook apps or Skype apps or whatever that app is, right? So Silicon Valley is going to play a huge role in this field now. So just to give an idea, when we talk about RAN disaggregation, there's a lot more components, right? Radio front end, physical layer, MAC layer, radio link control, PDCP, RRC, right? So we do not really get into each and every component level. What we do, at least with the 5G RAN, right? We break that into these broader components called radio unit, which deals with the radio front end. Mostly the hardware is still proprietary, is still at the cell site. But after that, the distributed unit and control unit, that's where I would say most of the innovations or software innovations can happen, right? And this can reside entirely on servers, open servers, and that's now given that they are softwareized and virtualized and programmable. That's where you can build this middleware where you can host APIs to control different aspects of RAN, right? And that's where the concept of Open RAN comes in, right? A little background: Open RAN is defined by this ORAN Alliance, introduced in 2018 by these four companies: AT&T, China Mobile, and so on. And here the goal again is to basically reset the RAN industry to make it more intelligent, open, virtualized, fully interoperable. Just choose more keywords. Okay. The core principles: openness, that's the key, right? We want everything to be open: the softwares, the servers, the interfaces, right? The applications, right? That's where the openness comes from. And as again, Dr. Reed mentioned, intelligence or AI native is a big part towards the realization of ORAN. It's flexible by design because of the open interfaces and APIs, and the RAN intelligent controller, which I think will become will play a pivotal role in coming years, even though it's not that, let's say, it's not that discussed yet among the vendors. Vendors are more excited about RAN disaggregation, the CU, DU, and the interoperability between them. But I think the RIC is actually going to be a big thing in coming days, and I'll explain you why with one slide. Just some motivation. See a lot of things going on in the country, from the government, from the academia, from the industry, right? And there's just too many. These are still old, actually, from 2021, 2022. Even outside US, we are seeing a lot of activity all the way from India, Africa, Europe, Japan. Japan is actually a leader in ORAN deployments at this point. Europe, right? So it's all over the world, not just in US. And this is our project, because of which we are all here, actually. So we are now familiar with RAN disaggregation, right? So now we connect this disaggregated RAN with open interfaces, and then we control those RAN components with RIC, okay? And then this RIC, as of today, is again partitioned into non-real-time RIC and near real-time RIC, just based on timing of the application need, right? If you need a really fast operating RAN control or monitoring, then you do that in the near real-time RIC. If you are okay with doing that on a more coarse grain level, then you can do that in the non-real-time RIC, right? So that's what it is. All these open interfaces, A1, E2, and then there are others, O1, O2, right? These all make sure that irrespective of where the CU, DU, and RU is coming from, irrespective of which vendor it's building those hardware, they still interoperate and work with each other, right? That's the beauty, or that's one of the major reasons why vendors or operators are mostly excited about it. Okay, why RIC is going to be a big reason, or let's say big thing in coming years. This is what I think. So with computers, right, we had these mainframes in early 60s, right? A big computer with dedicated application, with dedicated keyboard, like typewriter thing, right? And then, later in 1990s or so, right? These two guys, Steve Jobs and Bill Gates, right? They came up with this interesting idea of operating system, right? What did it do? It broke down the applications from the hardware, right? From the hardware, you have these hard disks, CPUs, network sockets, and all that. And then you have all these cool applications. But initially, the problem was that if you build an application, you literally have to go to the hardware and then control it, write it, all those things. But with operating system, You don't have to do it anymore, right? The operating system takes care of everything. You just do your application, and then operating system is the one who makes sure that your application gets what you need, right? You need networking capability, then the operating system takes care of it. Right? You need some RAM to run your application. You need some memory to write to the computer or to the thing. You can do that, right? The similar thing is going on with the cellular RAN. Okay, cellular network, which has never been done before, right? As of now, we still are dealing with hardware, right? We still have to implement a certain application, let's say load balancing, RAN slicing, switching, whatever that is, congestion control. You literally have to have a proprietary hardware. But now, because of the ORAN architecture and the RIC, which I like to call RAN operating system, right? The same thing happened with the networking, software-defined networking. Right? What happened? They broke down the control plane and the data plane, right? And then you don't have to do the switches anymore. Switches are literally the hardware fabric, but all the control happens in the network controller, right? And that changed the networking world, right? So I think the same thing is going on with the ORAN or with the cellular networks, and we are at the very interesting time of this transformation that's going on in the cellular networks. So right now it's still DOS. We still need it still take time to get to Windows 7, but we are right there. Okay, now the AI, and I don't need to motivate why. What are the opportunities of AI, right? And what are the applications that AI can contribute to, right? All the way from beamforming, scheduling, sharing, optimization, maintenance, operation, everything. There is a role of AI to play, right? And there's no end to this. We all are familiar with that. But to do that, what are the challenges? The challenges are that we don't yet have sufficient real world experience at a scale. We are still dealing with a couple of hardwares, potentially collect some data, use MATLAB to do simulations or collect some synthetic data, right? But that's not enough. If you really want to deploy an application, AI-driven application in a real world where the operator is dealing with millions and billions of dollars, they are not going to, trust the application if it's not tested in a real world environment, right? The another issue is that how do you do this extensive testing, right? It's very, very important, especially when your name and your money and effort is into that, right? And and AI doesn't help either, right? You do not know how AI works, right? You cannot explain how AI works, right? So that's another reason that people are really susceptible to applying AI in real world environments, right? So what are the key research questions? Several. How do we design cellular networks which are more AI suitable, not for everything, but potentially for those knobs that actually can help and has little risk or skepticism around it, right? What methodology apply to test AI performance? Testing is really, really important if you again want to do a real world deployment, right? Because again, you can't explain AI, you can't trust AI. So at least you should test as much as you can, potentially in all the different environments, so that you feel confident enough that it's gonna work, right? And so on. And that's where the OAIC comes in, right? The OAIC is this community research infrastructure. The idea is to again build, prototype these AI-driven RAN controllers, which could be in the form of XApp, RApp, depending upon where it's hosted in the rig, right? And then test. Testing is really, really key. Okay. Okay, so now I guess we are there to discuss OAIC. What's the mission of OAIC? Build this open platform, including software code, library, documentation, so that researchers like us are fully comfortable using the platform, again, for prototyping and testing AI-based RAN controllers. When I say AI-based RAN controllers, it could be XApp, RApp, or even if you build a real-time rig, which some of the colleagues I see have been working on. There is something called AgeRig from UCSD San Diego, who are building the real-time rig, and they call it Mu app. So they will be hosted in in DU, right? So again, that's another level of RAN control. It's based on open, virtualized, and programmable ORAN architecture because it meets our purpose. There is no point developing a similar architecture when there already exists one, right? So we leverage the existing architecture, existing software code. We don't want to, again, rebuild the things that's already out there. So we leverage SRS RAN and open air interface as our cellular software. We also are looking into simulation platform like MATLAB 5G Toolbox. Why? Because again, with this open cellular software, you need hardwares like software-defined radios, and you do not have thousands of those radios, right? So if you have an application or a RAN controller function that requires hundreds and thousands of radios, then potentially a simulation platform is a better way to go. So that's why we want to support simulation as well. We use OAIC software community code. As of now, it's release E for our RIC platform, and then software-defined radios if you're working with open cellular software. So like I said, it has two parts. One is OAICC or RAN controllers. The idea is to prototype AI-driven RAN controllers. And then the second part is the OAICT, Open AI Enabled Cellular RAN Testing Framework. So what is OAICC, which you already know by now, right? So OAICC is nothing but a ensemble or a integration of ORAN architecture, 5G NR protocols, and software-defined radios. Okay, or it could be a GMQ if you are using simulated radio links. So that's what it is. Okay. And then you can see the analogy here. So with ORAN component, for example, OAIC implementation, right? OCU, ODU, and ORU is coming from this open cellular stack called SRS RAN. E2 interface, we actually build that interface, or let's say integrate that interface, so because it's not available as of today, as of now. And then the RIC is coming directly from the OAIC, and then the XApp. So we have emulated the existing XApp, and we have built some new custom XApps. And then 5G code is coming from Open 5GS because it's needed for a 5G network to work. So now the features and capabilities of our first release. So on the near real-time RIC side, we support the near real-time RIC. We have not yet integrated non-real-time RIC. And the reason was that we were more interested in developing these AI-driven RAN controllers for the physical and MAC layer, right? And as you know, the physical and MAC layer requires sub-millisecond or millisecond kind of control. So that's where we were more focused on near real-time RIC and looking into the development of real-time RIC. But now we are also looking at non-real-time RIC. So it should be available, if not this release, in the next release for sure. Cellular stack, like I said, as of now, we support SRS RAN. We support 4G LTE, 5G NSA as of today. We are working on 5G SA. We have integrated E2 agent. We have also support for software-defined radios, USRPs, X310s, and B210s. Then we have 0MQ, and we also have RAN simulators that's available. And for the RAN controllers, the AI-driven RAN controllers, as of now, we are mostly focusing on XApp. So we have all these existing XApp working on our platform, like Hello World XApp, Bouncer XApp, KPI Monitoring XApp, which you are going to install and try out today in hands-on session 2, part 1. And then we have next RAN slicing from Powder, University of Utah, that we, again, replicated. And we also developed new XApp, like reinforcement learning-based admission control scheduling XApp coming from MSU, part of our team. And then OAICT test XApp coming from WPI. So the code and the documentation, most of you should be aware. If not, these are available publicly online. And these are the links. If you just go to openaicellular.org, our website, you'll find links to everything related to OAIC. Okay. So what's next? So in release 2.0, which is our short-term release, we are gonna support 5G SA again with SRS RAN. We are still working with OAI, so we are not going to make it available just yet. We are going to support the release F and G of OAIC near real-time RIC. We do intend to support non-real-time RIC and SMO in this release, but it's on the low priority, so it's going to take a lot of time. We are gonna postpone to the later releases. AI ML loop would be supported at least with the near real-time RIC. So the closed loop from the RAN, E2 to the XApp, and coming back to the RAN. So that loop will be supported. We are also supporting E2-like, which is not a fully ORAN compliant E2 specification supporting thing. We have that, but only for a few XApp. But for the control AI-driven loop, we have developed E2-like interface because it's not very easy to build the E2 following the exact specification. We are working on it, but it's taking time. It's a huge software development effort. We are gonna support multiple UEs. So we have extended 0MQ code to support multiple UEs. So you should be able to do that. Then custom simulator, we are working on that. OAIC sim, we like to call it. And then we'll be releasing more XApp. Interference classification XApp, it will be available. It's already accepted in Globecom this year. So it will be available. We are also doing a demo at the first SRS RAN workshop and also at the MinCom. The deep learning based resource scheduling XApp will also be available. And then the spectrum sensing XApp will be made available with low priority. But I think we have everything working, so it should be made available, even though I was not 100% sure at the time I was developing this. And that actually got published in JSAC Open RAN special issue. So you'll also get to see the paper. Long-term release. We want to support OAI because we see that there is a huge interest among the research community to have OAI-based ORAN platform. So we are gonna support that as well. We are working on real-time RIC. Like I said, UCSD has already done some version of real-time RIC. So we are also working with them or discussing with them on how to leverage existing code and integrate that with OAIC rather than we doing it, all the ground up. We'll see how that discussion goes. We'll be making more XApps, RFs, and then the near real-time RIC, the real-time RIC apps, whether it's called Mu app, D app, some people call it D app, some people call it G app. You see what I'm saying? But all these AI-driven RAN controllers available. And then the AI testing, OAICT, it will be discussed on day 2. So I'm not getting into that detail. I don't want to steal their thunder. Okay. And the question for you guys, what additional OAIC features you would like to see? So let us know. We'll be running a post workshop survey. So, do let us know. You can always reach out to our mailing list, get connected to our development team, right? And if you want to, let's say, contribute or leverage our platform for whatever purpose you want to do, we'll be very happy to talk about it, okay? So just a quick, let's say, look at OAICT, very, very quick. This is the only slide I have on OAICT. The idea is that it will be a third framework, okay? It's not a part of 5G network itself, but it's rather a third-party framework which will generate automatically different test cases to evaluate or test different aspects of a 5G ORAN network. For example, let's say you are testing a particular XApp, okay? Then you will be able to generate a lot of different test cases, figuring out what's wrong, or let's say what weaknesses exist in that particular XApp, for example, right? How does its performance looks like in various network performance metrics or other metrics that you may be interested in. So it consists of 3 parts: the server, which generates creates, interprets those test cases. And then we have an actor, which basically use AI. That's our intuition. We are not there yet on the AI piece, but we have a test, OAIC test working, which you're gonna discuss tomorrow. So that's the idea. So the timeline, the overall timeline of the project or of this platform looks something like this. So the OAICC code release, it will be made available on those dates as you see. So the first one was supposed to be Q4 of last year. The second one is supposed to be Q2 of this year. So we are actually right there to make our second release, and so on. For OAICT, it is after 1 quarter later than OAICC. And we, so this Q1, so we already made the first release in January. So it's available. And then all these documentation come along with those code releases. And these are the couple of workshops. So we are running, or we are currently in our first workshop. So we'll also have a second workshop next year, potentially in MSU. So our first release, we were actually ahead of our schedule. We released that in Q2 of last year. And then, like I said, OAICT, that was released in January because of the the Christmas break. So we had everything, but people were on vacation. So we waited until January to make that release. And then we expect our second release to be somewhere in next few weeks. How to get involved. So these are all the sources or resources for you guys to get involved with OAIC. There is a user group, OAIC website, mailing list. We also have a YouTube channel that we basically upload, different videos showing how to install OAIC, how to develop a new X app, and so on. This is our team. We have actually a lot of students working with us. So this would not have been possible without our students. So I'm really grateful for that. So thank you, guys. These are a relevant publication coming out of OAIC project. So if you're interested, for example, the first paper that explains, or that tells you how to prototype this next generation ORAN research testbed. And we have shown a couple of XApp, the RAN slicing XApp and KPI monitoring XApp. So you should be able to follow that paper as well. And there are a few other papers, as you can see. Just to quickly go through the agenda. Okay, so the interesting part is going to come after this talk. So we have divided our entire hands-on session into 4 sessions. Okay, the first session, it's about OAIC installation, which is just right after this, before the lunch break. And then we'll have the hands-on session 2, part A and part B. Part A is about getting familiar with XApp, with an existing XApp, which is KPI monitoring XApp. So you'll get to install the XApp, you'll get to play with the metrics that KPI monitoring XApp does. You'll get to, ask your question, whatever, questions that you may have. Then we have a 30-minute networking break. And then we try to build a brand new XApp, which is based on AI. So basically the idea is that you'll be able to wrap a machine learning model as an XApp and run it on data, okay? And then you'll be able to control the RAN using that XApp. So that's the goal of that session. And finally, from 5:30, we'll have a poster presentation right here in this room. So you'll get to, you'll get to rate the poster. We are working on that UI. So you'll get to rate that poster, which one poster you like, and then the one which has the most vote will be declared a winner in tomorrow's closing remark. Okay. And tomorrow we'll go through the OAICT. Okay, and there will be the last hands-on session, which we call hands-on session 3, which is about OAICT installation and testing an XApp. Okay, so that concludes my presentation. Thank you. Questions? How are we doing on time?
Yeah, good.
Okay.
Very good. So there is one Zoom question.
Okay.
So what is the role of the interface? Is there any difference between O1 and E2?
So these interfaces are what makes ORAN so unique. Okay, so think about a computer, right? For example, let's say you want to connect a USB to a laptop, right? There is an interface, right? The USB 3.0 or whatever that is, right? So it's very important that a particular hardware, developed by any vendor works with another hardware, developed by another vendor. So both the hardware must be able to support that interface, right? The same with the electrical sockets, right? If you're in US, irrespective of where you take your phone charger or laptop charger, it works. Why? Because the sockets follow a particular interface which is acceptable throughout the country, right? So similarly in ORAN, okay, the E2 interface is between the RIC and the RAN. So let's say a RAN is coming from, I don't know, Nokia, Ericsson, right? And then the RIC is coming from Mavenir, for example, right? Then how is that RIC going to control that RAN? So both of them must support E2 interface, okay? The ORAN compliant E2 interface. So that's the role of that. Similarly, O1 is a different interface for collecting the data from the RAN to the RIC, okay? E2 is about controlling the RAN. You can collect test data, but the actual data, the raw data actually gets collected for, let's say, training purposes or whatever that is. That gets collected through O1 interface. And there are other ORAN interfaces like A1 between non-real-time RIC and near-real-time RIC. Then we have some open fronthaul interfaces. We have several interfaces in ORAN. So yeah, I hope that answers your question. Okay. Any other questions? Yeah, Daniel.
Curious if the development you all are doing, particularly with describe kind of just the full control loop of taking information from the network into your XF information control. Is it development happening exactly you all are pushing after?
Yes, so we are making it available through OAIC, right? We are also trying to contribute to the OAIC software code. We don't know how to do that yet, but we'll definitely explore that once we become a member. We are still in the process of becoming a member. So once we become a member, we are definitely going to do that. Okay. How do we test AI-based RAN with real-time data? Is there any collaboration with seller vendor to get the data? Well, that's a really good question. So we don't have any existing collaboration with seller vendor. Even if we do, we cannot make them available through OAIC. So those data will actually be collected on our own platforms. Okay, so we do have Cornet, for example, 48 radio here in this campus. We also have like 14 node at George Mason that we are going to collect data as well. We are also going to leverage AirPower, which Dr. Book is a co-PI on that power platform. So we're going to leverage existing wireless testbed, install our OAIC platform, and collect data and make them available as we can. Okay. If no more question, then I will hand it over to Joe.